Hello everyone, happy Sunday. Welcome to another episode of my YouTube channel, Data Science with Sam. This vlog is a continuation of the series on natural language processing that I started last month. In my previous vlog, I gave you an overview of how you can build your first text classification model in order to distinguish a series of datasets into non-disaster and disaster traits. If you missed that vlog, I'll definitely recommend you to go back to my channel, watch that vlog before you move forward with this one. And please don't forget to like, comment, and subscribe to my channel as more contents on natural language processing are forthcoming. In today's vlog, I'll continue the same text classification exercise where I left in my last vlog. In my last vlog, you saw an overview of how you can perform binary classification. So now in today's vlog, I'll give you a similar sort of overview of how we can build text classification model in order to perform multi-class level classification. So in today's vlog, you will see that there are more than 2 categories that I'm going to actually categorize as a part of the text classification exercise. So let's get started. So as you can see, this Jupyter notebook will be already shown in my previous vlog. So I'm not going to give you a full rundown of this Jupyter runbook. Rather, I'm going to show you some key parts that will be applicable for today's exercise. So the first thing is obviously you have to load all the relevant NLP libraries. So these are the libraries that will be very useful for Python programmers in order to perform NLP exercise. The next step is to load the data. So since I'm actually building a text classification model in order to distinguish COVID-related tweets, so I need to first load a data set with lot of COVID-related tweets on Twitters, right? So the main purpose of this data set is it comprised of a lot of tweets, and there are like 5 categories mentioned in those tweets. Like for example, and this data set has like 5 different categories such as positive, negative, extremely positive, extremely negative, and neutral. So that means that the data set will have those tweets which provides kind of like a user sentiments, whether it's positive related tweet or negative related tweet. Like for example, if I elaborate a little clearly here, that the positive tweet means during COVID, during pandemic time, if certain news circulated, like if somebody tweeted about vaccine, if somebody tweeted about the positive aspect of the reduction of the COVID cases, so in those kind of tweets would be considered as positive tweets. Whereas in some cases, if you see the tweets that are related to like rapid COVID cases going in a certain location, or there's a grocery store is running out of supplies. So those kind of tweets will be classified as negative tweets. And there will be some tweets which will not fall into either categories, any of those categories. So in that case, we'll just consider them as neutral tweet. So this data set, which I loaded to Jupyter notebook, is comprised of 5 different categories. Like as I said, extremely positive, extremely negative, positive, negative, and neutral. But in order to simplify my classification, exercise, I grouped the extremely positive and positive category into one single positive category and perform the similar thing for negative tweets as well. So now I kind of after performing this additional preprocessing step, I kind of like I would say like bring down the categories from 5 to 3. So now if you just perform a routine EDA check or experience analysis check, you would see that the data set is comprised of more positive tweets than negative and neutral tweets. Additionally, I came across this Pandas library called Pandas Profiling that will give you an experience data analysis report based on a summary analysis of the data set. And this kind of library could be very useful for other exercise as well. Like for example, if you deal with some sort of like unknown data set, when you are not very much aware of the columns and identifier of the data set, then I will definitely recommend you to use this library, Pandas Profiling. It will give you a very like a brief overview of the data set, which might help you to understand the data a little better. And I guess you're curious about how this particular EDA report looks like. So this is kind of like a snapshot of the EDA report. So yeah, like it will give you some descriptive statistics based on different variables. It will give you the location of the the different tweets came from. It also gives you like when the tweet was at. So if you want to like filter down the data set based on different location or the either the timing or the date, then this kind of EDA report will be very useful. Also, you can see there will be some missing values reported. There are some columns where you won't be able to find those values. So if you want to get a quick missing value matrix, so this sort of EDA report will be very beneficial. Now going back to the main Jupyter notebook. So after we get done with some sort of EDA exploratory analysis, then we'll perform text preprocessing. As I mentioned in my previous vlog, that you have to perform quite a few different level of preprocessing in order to remove a lot of junk characters, punctuations, and like HTML tags, white spaces from the original tweet. And similarly, you also have to perform some sort of mechanism called, like stop words, where you're actually removing some of the stop words like A, D, or those words usually don't contribute anything to the underlying meaning of the sentence. So you remove those stop words from the sentence before you proceed forward with the modeling step. Usually, I don't recommend users to follow stemming mechanism, because sometimes stemming chop off the last character, first or last character of the word, and eventually that has an adverse impact on the underlying meaning of the sentence. So I usually recommend user to avoid stemming process, but you can obviously use limit addition. So after we apply those final pre-processing, make a final pre-processing step on the original tweet, then we kind of just, I would say, we clean the tweet, we remove all these junk characters, and then transform the original text into a clean tweet format. And that clean tweet will be the main input data to the text classification model. The next step is just to I would say that segregate or split the trained data set into train and validation data set. The reason we usually perform this additional splitting, because when you when you actually leverage multiple models, sometimes it's beneficial to use a validation data set in order to compare the performance of various models. Like here, you're going to use that trained data set for training the model, and you use the remaining validation data set to calculate the accuracy of that particular model. And once you get done with validating the model using that validation data set, you compare that model performance with that of others. Okay, like for here, we are going to use 3 different models. Okay, like we're going to use logistic regression, naive Bayes, and also use logistic regression on other models. So in that case, the validation data set will be very useful to compare the performance of the model. So now, having said that, the next step is to talk about the models. So as I mentioned that we are using this validation data set to compare the model performance. That means we're definitely going to use, and that means I'm definitely going to use like multiple models here. So my first model is based on TF-IDF mechanism. So as we know that for the term frequency mechanism, we put more emphasis on generating the frequency of the words appeared in the sentence, and based on that, we formulate the vector. So, and then after we formulate the vector, we kind of apply logistic regression technique on that vector for text classification exercise. So we're going to perform the similar thing over here. So after we went through that step, after we apply the logistic regression on a TF-IDF format, trained dataset format, then we came across this accuracy matrix. So it seems like the model performed reasonably well when you apply logistic regression coupled with TF-IDF mechanism. So now the next step is the naive Bayes. This is, so I'm actually using another additional model here, because another classification model here, because sometimes we've seen that naive Bayes is perform well than logistic regression in some certain scenario. So here we apply the naive-based model on similar TF-IDF frequency corpus. But unfortunately, we haven't seen similar performance or better performance in naive-based in comparison to logistic regression. Now, the next one is what to wake. So this is the new model I'm actually going to talk about in today's exercise. So for the what to wake, what we do is we perform the what to wake model, and in order to vectorize the sentence first, okay, and then perform the term frequency mechanism. So it's so in general, in theory, it's an opposite of TF-IDF mechanism. So in TF-IDF, we basically we generate the frequency of the words, and based on that frequency, we formulate the vector. But for the what to wake model, we formulate the vector first, and then after that, we apply that vector using different classification model, whether it's logistic regression or naive Bayes. So now, this code section will give you an idea of how you can build a what to wake model using a different mechanism during different function, like this mean embedding vectorizer. It's one of a function that will help you to transform the what to wake. We do have a what to wake model coming from one of the Python library, and so you can always check more about this what to wake model, and there is a lot of articles out there in the internet. So once you formulate this what to wake model, then the next step is to just apply the same logistic regression mechanism on what to wake model. So when you perform that, your first step would be to okay, so instead of passing the TF-IDF train dataset, we pass the vectorized format of W2V. And after we run the confusion matrix classification report, we came down to this accuracy levels, which is quite less than the logistic regression model using TF-IDF mechanism. So that there's a reason why we've seen some downfall of performance while using the W2VEC model, what to VEC, because in my previous experience, I've seen that what to VEC model works better when you deal with a paragraph or document. But here we are actually dealing with tweet. Okay, we're dealing with a one line of sentence or multiple line of sentence, and most of the cases those sentences don't follow a proper grammar, or there is a lot of junk characters out there. So that kind of I guess hinder models accessibility, what to VEC models accuracy. So sometimes it impacts the model. So most of the cases I would recommend that when you're performing text classification based on tweets or social media post, I recommend you to follow the TF-IDF mechanism, because that relatively performed well, better than what to VEC. But when you're trying to perform a similar sort of exercise based on a paragraph, document, or article, like for example, if you're performing a document summarization exercise as a part of your NLP task, then you can definitely use what to VEC model, because as it seems like what to VEC model performs better when you have more characters, more large corpus of text associated with the input data set. Similarly, in one of my future blogs, I will also talk about BERT. Okay, so BERT is also a more advanced model, more advanced, it's better than what to VEC in TF-IDF in terms of summarizing the text and also classifying. So we'll talk about that in one of my future blogs. But for now, I just wanted to give you a brief overview of how we can perform text classification using what to VEC as well. And in future, if you want to perform similar sort of COVID tweet analysis or any sort of tweet analysis, always remember that you need to focus on TF-IDF before you move to the what to VEC model. So TF-IDF, it seems, and based on this exercise, the result of this exercise, it seems like the TF-IDF model works better than what to VEC model. So now, since we already compare the accuracy or the performance of various models, then I'm I went ahead to apply the final the model as TF-IDF, because the TF-IDF model showed better accuracy in comparison to work-to-vec. So after I applied the TF-IDF on the final 20% test data set, I came across this accuracy matrix, which is relatively okay given the fact that there is still a lot of scope of improvement might be. We can still synthesize the input data. Maybe we can remove some more additional characters to make sure that the data will be easily comprehensible by model. So there are always scope of improvement, but at the first shot, I think 80% accuracy is pretty reasonable for any primitive level of primitive NLP model. So that's all. So this Jupyter notebook will definitely kind of like give you an idea of how you can build a text classification model using various mechanisms to classify a COVID-related tweet into different categories. And if you also want to like take a look at this COVID tweet submission or CSV, like the final output, I can give you a quick overview of that as well. So yeah, here you can see like so this particular find hand sanitizer, right? As in fact, it's going to festivals too. So again, this tweet doesn't make such sense. So, but still it's kind of considered as positive. Find, protect, love, one coronavirus. Obviously, positive tweet, because it's kind of showing the sentiment of like, we have to be compassionate to each other. We have to protect our loved ones during the pandemic time. And let's think about some negative thing. Pharmacy, full sick people. So this pharmacy, full sick people, this obviously showing that the frustration of like, like how the COVID cases are rapidly increasing. Also, like, if you check this coronavirus, fear, shopper, stock. So these kind of words are kind of giving you a negative meaning. And like during pandemic, I've seen so many cases, people went to grocery store and the stores are running out of supplies and they got panicked. Some people did panic shopping and they started tweeting about that. So these are all like a negative tweet that associated with our user sentiment. Now, let's check out if we find any neutral one. Yeah. So this is the neutral one. So as you can see, your stockpile food supplied by extra local food may family will luxury spend. So here, I mean, this particular tweet, I feel like even if it talks about food, supply, stockpile, but I haven't seen any positive or negative wording in that particular sentence or in a particular tweet. So in those cases, the model would distinguish or categorize that tweet into neutral category if it doesn't find any tweet or any word that signifies positive or negative sentiment of user. Okay, so that's just kind of a quick rundown of the final report published by, or the final prediction by that logistic regression coupled with TF-IDF. So I would definitely recommend you to try to check the what-to-fake model as well. Try to just use this Jupyter notebook and maybe create another code section and apply the what-to-fake model from here on the test data set and see how it performs. I mean, you can also like follow the same coding technique and you can just export the final prediction into a CSV file and see that how the model categorize specific tweets into different sentiment classes. Okay, so that's all for now. Hope this exercise, this vlog will give you an overview, like how you can build your text classification model. In future, you can always like play with different data set, tweet data set. It doesn't have to be related to COVID. And I'll also recommend you to check if you can find a better COVID-related data set that will give you, better sentiment analysis. So this is actually part of a sentiment analysis which we usually driven by NLP models. In my next blog, I'll continue this sentiment analysis technique. I'll give you an overview of how we can perform similar sentiment analysis technique on Netflix movie review dataset. So because Netflix and other streaming platforms use a similar sort of technique in order to understand their user sentiment, and based on that they redefine their strategy. Or if, like, for example, if movie gets like a lot of bad negative reviews, they usually try to take a movie out of their platform. So they usually perform similar sort of sentiment analysis to understand their users sentiment, user feedback, and make change in their product strategy, or change their product review process accordingly. So that's all for now. Hope you like this video. Hopefully it will give an overview of certain things. I already shared the the GitHub link of this Jupyter notebook in the video caption section. I'll definitely recommend you to take a look at it, maybe load it into your Python Jupyter notebook, and do some analysis on that. And if you do have any further question on the notebook or the Python script, please feel free to reach out to me and share your comments in the in the vlog section. And also, please don't forget to like, comment, and subscribe to my channel, as more contents on NLP are forthcoming. And till then, goodbye. I wish you a very happy weekend ahead, and I'll see you next time. Thank you.